this is what's called a submersible pump, and this is what we use to get the water out of the hole. You can see that it's electric powered, and we have it already connected to a stick or a piece of riser pipe. The parts of the pump, this part here is the actual motor, and you can see here the electric cable is routed down here and runs this as an electric motor. This part here is what they call the bowls, or the pump. It's like a little turbine inside there. It rotates around because of the motor. This section right here, this is the intake. So this is where the water enters the pump. This is the part that you have to keep submerged. In fact, you want to keep the whole pump submerged while you're pumping, because it's that water cools the pump and helps keep it from burning up. One more thing that I want to point out here is this little sucker right here. This is a backflow valve. It's a backflow preventer. And what happens is, once the water gets sucked into the pump and fills up the riser, you really want to have a backflow preventer, because when you turn off the pump, if you have a column full of water in it, two kind of bad-ish things can happen. One is all that water can drain back out through the pump, and that runs the pump backwards. It's not particularly good for it. But the other thing is, when you shut off your test, if you don't have a backflow valve on it, all that water runs back out of the riser and will fill up the well again, and that ruins getting any kind of recovery data at the end of the test. So you should always have a backflow valve on your pump. It's a really important piece of safety equipment. This is called the landing plate. This sits on top of the well casing. You can see it's got a handle, and it's got a slot cut in it here. And the slot is just big enough for a piece of riser to get through, but not big enough for the collar on each piece of riser to go through there. So the collar sits on top of this, and it keeps the pump and the rest of the assembly from falling through to the bottom of the hole. It's a really important piece of equipment in terms of safety, not just for setting up with the riser and getting in the well, as you'll see when I do the put it in the well, but also it's really important because if you just depend on the cable or the line to keep the riser up, that is something that can fail, and you can drop the pump down the hole. And so this is a safety thing that keeps that entire string from going to the bottom of the hole. So this is the well that we're going to put the pump in. This is B16D in the University of Idaho Groundwater Field Laboratory. And what we're going to do is we're going to position the pump over the well. We're going to connect this line to the well. So typically, in a situation where you have a full hoist that's tall enough for all of your riser sticks, you would typically have a swivel on top, and you would screw those into the riser and lower those. We don't have a hoist that's tall enough for that, so we're going to hook this cable on to a little attachment point on the riser, and then we're going to lower it down one stick at a time. We're going to put the pump in the hole here. Alright, you can go ahead and lower it. When you're putting the pump in the hole, you have to hang on to the electrical line, because the electrical line has a tendency to get jammed up. If you just let it hang free, it'll get jammed between the pump and the well, and then you kind of have a little bit of a mess on your hands. Okay, we got the landing plate on there, the safety thing, so the collar's going to sit right on top of that landing plate and hold the string when there's no tension on the line. Alright, people often, or occasionally anyway, ask me if we should put Teflon tape on, plumber's tape, on the joints. And I actually don't do that, and there's a simple reason for that. I think we don't really care if there's a small bit of leakage. No, it's usually plenty good without it. We do put that on the discharge line though. Okay, these are what pass in small situations like this for drillers' tongs. On a big drill rig, there will be like hydraulically ram operated, or they'll have it on a table that'll turn the joints. And here we just use pipe wrenches. Alright, so you're going to lift it up just a little bit. Lift it up. Oh, you have to, yeah, no, the other way. Okay. Alright, now you can let it down. Okay. Let it down. And we're just going to repeat this over and over again. You always want to keep count of your sticks. Each one of these sticks is 10 feet long. The first one is a little more than that. I think it's about 12 feet. It's got the pump on the end. So once this collar is sitting here, then the pump will be about, that's 2 sticks, that'll be about 20 or 22 feet below top of casing, TOC. Doing your test plan, because you need to figure out how deep is the tensiometric surface, how deep is the water level in the well, and then that gives you some range. You know that between that distance below top of casing, and you got to whatever that is, subtract that out, and that's how much drawdown you can get before you get to the pump. We're going to attach this manifold. Because we're going to be pumping, water's going to be coming out of here. We need to lead it away first to some kind of a flow discharge gauge, or some way we can measure the discharge, and then we need to discharge it away from the well so it doesn't just recirculate into the water table. So the first thing we need to do is change the direction. Actually, can you give me some slack here? Sure. No, the other way. Okay, that's good. Okay, so we got this manifold on. Now, we've got this little assembly here that I've put together. You can see there are 2 gate valves. Here's our discharge gauge, or discharge meter. And we're going to want it facing off this way because we're going to run the water out onto the ground away from here. This is always tricky because you want the discharge meter pointing up. You don't want to over tighten it because that's going to kind of screw you up. So that's about good right there. And now we have this set up. You can see our control valves here, gate valves. This one we want to keep open. This one is the one we're going to use to control the discharge on our test. And then this is how we're going to read the discharge. Discharge hose. So usually use some kind of a flexible hose. It could be hard line, but we typically use a flexible. This is sort of a, I don't know if you want to call it a fire hose, but something like that. And so this is just a slip connection here. Okay, and now we're going to run this line off into the field here and just discharge the water on the land. The discharge gauge, and I hope you can see this. It actually doesn't measure discharge, it measures cumulative volume pumped. And so the way you read this gauge, you see there's a little kind of an odometer thing here, and if you look closely, maybe I'll see there's 2 blue zeros after the end. So the way you read this, it's 1, 4, 5, 7, 0, 0. So since I bought this discharge gauge, this particular one, I've run 14,500, no, sorry. I have run 145,700 gallons past this gauge. But then you see there's a vernier gauge on the outside. And if you look, it goes from 0 to 100 is one complete revolution. And right now it's sitting at 90. So if you put those two things together, you get 145,790 gallons that have been pumped through this discharge gauge since I bought it. Okay? And so when you want to know discharge, you don't really, this doesn't read discharge, it reads gallons. So what you have to do is you note how, like the time, and you time it for 1 minute or 5 minutes, whatever, and you see this vernier dial, how far that moves, and that in 1 minute, that's how many gallons per minute, or in 5 minutes, you divide by 5, and that's how many gallons per minute it's pumping.